Good morning, students. Today we are going to study about module number 5, that is microprocessor and microcontroller. As you can see over here, it is known as an functional block diagram and architecture of MSP 413. One by one we are going towards the functional block diagram. The first block which is being connected is called as a system block with respect to oscillator. The second one is CPU, third KB, 8 KB flash, 4 KB flash, 256 RAM, random access memory. Then input output ports, you can see over here the input with respect to interrupt. There are three input output ports: GTAC, which is called as a joint test action group, watchdog timer, normal timer, port, comparator, and usage. Over here the lines which is called as in control lines, which is been dealing with your memory address bus and memory data bus. What over here we are going to do is we are going to study now each block one by one. As on we are going to start with respect to the oscillator or else the system clock. Very first thing what I am going to explain you is the oscillator is used to generate the clock signals for the internal units of the microcontroller. The second one, which is called as an CPU, over here the CPU of the 16-bit 16-bit with 16-bit register is present in the microcontroller. This is capable of performing 16-bit operations simultaneously. Flash memory, as you can see over here, the flash memory can be programmed via the GTAC port. The GTAC port is called as a joint test action group port. Bootstrap, one minute. As we can see over here is bootstrap loader or in a system by the CPU. The CPU can perform single byte and single word with respect to the flash memory. The next block is called as a watchdog timer. Watchdog timer over here, the primary function of the watchdog timer, that is WDT module, is to perform the control system restart after the software problem occurs. If the selected time interval expires, a system reset is generated. The next, I repeat again for the watchdog timer. The primary function of the watchdog timer module is to perform the control system restart after the software problem occurs. If the selected time interval expires, the system reset is generated. Usage 0. The MSP 430 devices has one hardware universal synchronous and asynchronous receive transmit peripheral module that is used for serial data communication. The USART supports synchronous, that is serial peripheral interface, and asynchronous USART communication protocols using the double buffer transmitted received channels. The second block, which is related to the timer over here, as a timer is a 16-bit timer counter with three capture compare registers. The timer can support the multiple capture compares, which is a feature of MSP 430. PWM outputs and the interval timing. The timer also has extensive interrupt capabilities. Comparator over here. The primary function of the comparator module is to support the precision slope, analog to digital conversion, battery voltage supervision, and monitoring of external analog signals. Over here in the last block, we can say that it is an analog to digital conversion. Analog to digital conversion 12 modules supports fast 12-bit analog to digital conversion. The module implements a 12-bit SAR code sample select control reference generator and a 16-word conversion and control buffer. The conversion and control buffer allows up to 16 independent ADC, that is analog to digital conversion, samples to be converted and stored without any CPU intervention. Now, as we move towards the program counter, as we move towards the program counter and stack pointer. So the program counter over here holds the address of the next instructions to be executed by the microcontroller. The stack pointer points to the top of the stack. The stack is used to store the data for some temporary time. It is used to store the return address when the function is called. Stack pointer is a word assigned, that is, the LSB is always 0. The storage of data on stack is called as a push operation. Now, the stack is a reserved area of the memory where temporary information may be stored. A n-bit stack pointer is used to hold the address of the most stack entry. The microprocessor stores the information, the data like stacking plates, but and it removes then stacking plates. If we have to remove the first stack plate, then we have to remove the all plates above the first. That is, we have to remove the fourth, third, second plate, and then finally first plate if all the plates has been placed properly. There has been a registers with respect to R2, R3. In that we are having the flags. The flags over here, which is also called as a carry flag, zero flag, negative flag. There is in general interrupt enable, central processing unit, oscillator off, overflow flag over here. Each and every register is being connected with respect to the flag. The instructions of the MSP 430 are 16-bit long. What are the instructions? Whenever we need to execute any of the program, there are certain things which we have to keep in mind. That is, first we need to fetch the data, decode it, and then execute the program. Whenever you need to execute the program, the first thing you need to write the instructions which the microcontroller need to understand. We had already read there are certain instructions of microcontroller. There are 27 basic instructions of reduced instruction set computing, that is RISC format, and 24 emulated instructions of complex instruction set computing. So the MSP40 has an 16-bit register. Some of the instructions can work on both, that is 16-bit data as well as 8-bit data, while some others can work only of 16-bit data. The instructions are basically of three formats, namely source destination format, single operand destination format, and branching format instructions. The basic instructions according to these three formats is been indicated that the instruction supports byte as well as the word operation. So students, over here as we have studied the MSP 430 functional and its architecture, so it is very important that in university exam all these things, the this microprocessor and microcontroller, this question that draw and explain the functional block diagram and architecture of MSP 430 is very much important, and we have to explain each and everything. Okay, thank you. Hope you have understood all the blocks carefully. Uh, do like my do share the channel and subscribe it. Thank you so much.